Hello viewers, once again welcome to my new lecture. This lecture is for all medical professionals. As you are watching me, so I am Zahor Islam. Today I will teach you about the basic concepts of organic chemistry. So as we know that organic chemistry it is the branch of medical sciences in which we study about the organic compounds. In this lecture we will cover, these are the objectives, to recognize the importance of organic compounds, compare the property of organic and inorganic compounds, describe the classification of organic compounds, differentiate the types of hydrocarbons, saturated and unsaturated hydrocarbons, describe the molecular composition of carbohydrates, proteins, fats, nucleic acid, list a functional group, that is alcohol, ether, aldehyde, ketones, acid, ester, amines, amino acids and amides. Write equations for the formations of alkenes, alkanes, aldehyde, ketones, acids, esters, amines and amides. Discuss the biological importance of various aldehyde, ketones, acid, ester, amines and amides. Distinguish between primary, secondary and tertiary amines and explain the structure of amino acid. Discuss isomerisms with at least two examples. So all these are the course objectives, and inshallah we will cover all these course objectives in few lectures. Okay, so let's take a start. What is organic chemistry? So organic chemistry in simple words, it can be defined as the study of carbon and carbon compounds. So whenever you see the name of organic compound, so it means that carbon is a major and constituent element. Organic compounds are the primary constituents of all living organisms. So as you can see, this mean that organic compounds are those compounds in which the carbon is acts as a major element. For examples, you can see here, this is drawing electron dot diagram of carbon. So let's see. Okay, so this is carbon, and then this is the dot diagram of carbon. So 1, 2, 3 and 4s. I mean, these are the 4s, you can say, electrons, which are surrounded by the carbon atoms. This is dot and cross models. This is another one. Let's see here. This is, I think, so it means that carbon is able to form 4 covalent bonds, mean the 4 valence electrons with the other carbon or other elements. This is very easy to understand, that carbon is capable, it is the tendency to form 4 covalent bonds simultaneously, because it is 4 valence electrons with other carbon or other elements. Seconds, so you can see here the what are the features and characteristics of organic compounds. Organic compounds are non-polar compounds, and they do not dissolve in polar solvents, so like water. So water is the classical example. So we are unable to dissolve the non-polar compounds in polar compounds. Look at here. So this is that show polarity, while this is non-polar. So that's why you can see the non-polar compounds, it cannot be dissolved in polar solvents. So this is in simple word, this is water molecules. Remember the rules, like dissolve like. This is hydrogen, partial positive charge, while this is also hydrogen positive, and this is oxygen negative. As we know that oxygen is electronegative while hydrogen is electropositive. So this is actually the bond between low electropositive and high electronegative atoms, and this is the classical example of water molecules. Another feature of organic compound, they have low melting points due to weak intermolecular force between the molecule. Now you can see here, so this is actually the carbon atoms. So two carbons, they are attached by this, they are bonded. This is a single covalent bond which is present between two carbon atoms. Let's see here, this is weak. So this situation, so intermolecular forces are it means that intermolecular forces, they are weak. That's why they have low melting points due to weak intermolecular forces which is present between these compounds. Especially in organic compounds, they react slower than ionic compounds due to strong covalent bond between atoms. If we can compare the bonding situation of ionic bonds with the covalent bond, so in this case the reaction is slower than ionic compounds due to strong covalent bonds between atoms. Now here the situation, so the covalent bond is strong. The covalent bond, this is strong. Okay, so this is another situation. So you can see here is also the interaction is strong. Now come toward the structural formula. So the structural formula, the 2D model shows bonding pattern in shape of molecules. Carbon is found in the center. The short line represents a pair of electrons. You can see here. This is what you can say. It shows the short line. It represents the pair of electrons. That the electrons are paired. They are in the form of pairs. Now in this example, you can see here that carbon is surrounded by two hydrogen atoms. So 4 hydrogen atoms, they are attached on different sides. Okay, so another thing, I think this is very easy, you can try it. So try the structure of each organic compound, that is methanes, which is alkane. Actually its chemical formula is CH4, chloroform is CHCl3, ethane is C2H6. Look at here. Now you can see the structural formula of methane. So this is, I think, clear. So here in this case, with one carbon, there are 4 hydrogen atoms which are surrounded by these atoms. For example, the carbon that is surrounded by 4 different hydrogen atoms. Now let's see here, this is chloroform. Its chemical formula is CHCl3. Okay, now I would like to draw it sketch. This is carbon. Look at here. So one hydrogen is attached here. Chlorine is here. Chlorine is here, and chlorine is here. So that's why its formula become. So it means there is one carbon atom, so one hydrogen, one hydrogens, and the third one is, you can see this is 3 chlorine atoms, so they are attached on different sides. Now look at the ethane, C2H6. Carbon, carbon, because there are 2 carbon atoms. Look at this is the bond. Strong bonds, or you can say covalent bond between 2 carbon atoms. And look at the different position of hydrogen atoms which are present around the carbon atoms. 1, 2, 3, 4, 5, 6. Okay, so remember that carbon has 4 binding sites. How? It means carbon is 4 binding sites. For example, this is the central atom. This is 1, 2, 3, 4. So there are 4 binding sites of carbon. Okay, so now come to our types of bonds. types of bonds. One is single bond. Single bonds, when there is a single covalent bond in which they share one pair of electrons, or you can say one pair of electrons or two electrons. Let's see here, these two carbon atoms, they are attached with one another. This is what one electron is present, surface of carbon. This is another one, this is another. This is clear. Now let's see here. Okay, so here in this case there is a single covalent bond present between carbon atom, and they just shared one pair of electrons. This is called one pair of electrons or two electrons. So as we know that carbon is surrounded by the 4 hydrogen atoms. Now look at the double bond. In double bond, the carbon atoms may share two pairs of electron to form a double bond. How? You can see here in the, you will draw the structure. So this is what, there is a double bond present here. So you look at here, a double bond is present between two carbon atoms. Now let's see here, this is carbon, it's also carbon, so it can share two pairs of electrons. As we know that, okay, so that is declared situations. These are two pairs of electrons, or the total number of electrons, they are 4 in numbers, and as we know that. Okay, so now in this case the carbon atoms may share two pairs of electron to form a double bond. Now this is triple bond. In triple bond, the carbon atoms may share three pairs of electron to form a triple bond. Now let's see here, there is a triple bond, triple covalent bond present between two carbon atoms. Now let's see the mutual sharings of electron, how the atoms can share three pairs of electron. Now let's see, this is yellow and this is black. Okay, let's see here, these are three pairs of electron to form a triplet bond. The same situation is here. So I means that there is a back difference between single, double and triple covalent bond. Now this carbon atom can share three pairs of electrons to form a triple bond. Okay, so now come toward the types of compounds. So types of compounds, when it's saturated compounds is, they are those organic compounds and with the carbon atoms are bonded by a single bond. For example, methane, CH4. So this is clear, there is a covalent bond present between carbon, hydrogen here, and I mean that 4 hydrogen atoms, they are surrounded by the carbon atom, by the central carbon atoms. Let's see. Okay, so these are saturated compounds. So saturated compounds, these are actually called, you can say, alkanes. Alkanes are saturated. So unsaturated compounds are those where the carbon atoms have double or triple bonds. I mean, in this case, it cannot be further broken down into simpler ones because due to single bond. While in unsaturated compounds, so the compounds where the carbon atoms have double or triple bonds, for example, ethene, so C2H4. The chemical formula of ethene is C2H4. Now look at this situation. This is the structural formula. So here the two carbon atoms, so they are attached with one another by double bond because the number of carbon atoms, they are 2 in number. Now let's see here. Okay, the total number of hydrogen atoms, that is 4 in number. So I think this This is the structural formula, while this is the chemical formula bethene. So I think that is very easy to understand. Okay, now let's go towards homologous series of hydrocarbons. So inshallah, in my next lecture we will talk about the homologous series of hydrocarbons. So if you have any questions regarding my lectures, so I am always available for your services. So it is requested to all my viewers, those who are watching my lectures on regular basis, so kindly do subscribe my channels, watch it and press the bell icon for upcoming lectures. Thank you.